In this activity, you guys are drawing a few similar triangles by hand using a ruler and compass. I thought I'd show you how you can do the same thing on Geometer Sketchpad. Now I'm going to be using a few of the features of Geometer Sketchpad that we haven't gone over before, and some of them are a little bit advanced, but I'll explain everything as we're going. So first off, on the activity it says that we're supposed to draw a line segment 5 centimeters long. So on Geometer Sketchpad, you can do a line segment that's exactly 5 centimeters long by first putting a point on your page and then going up to transform. Now we're going to translate that point 5 centimeters over horizontally. So now I've got 2 points that I know are exactly 5 centimeters apart. And I'm going to join those 2 points with a line segment. So now I have a line segment that I know is exactly 5 centimeters long. Now from there, using a compass, you guys are asked to measure a distance of 4 centimeters away from one point and then pivot it on one of the ends of the line. Then you guys are supposed to use a compass to draw another arc that is 3 centimeters away from one of the points. So I'm going to do that on Geometer Sketchpad using circles. So first I'm going to highlight just one point, and I'm going to translate that point 4 centimeters up now. So now that point is 4 centimeters from this point. And what I'll do is I'll connect those 2 points using a circle. So that'd be the same as if I measured using a compass and put the 2 points of the compass 4 centimeters apart and then pivoted 4 centimeters all the way around this point here. Now I'm going to do the same thing on this point, but I'm going to draw a circle with a radius of 3 centimeters. So first I've got to deselect my circle, select my second point, and I'm going to translate that one 3 centimeters up. And then I'm going to draw another circle to connect them. So now, from your activity, you guys are asked to join the points where the 2 arcs intersect to the endpoints of the 5 centimeter line segment. Okay, so over here, that would be either this point or this point, and it doesn't really matter which one I choose. So I'm going to choose the point on top. In order to get a point exactly where those 2 circles meet, I'm going to highlight my 2 circles, and I'm going to construct their intersection. So now that puts a point right where those 2 circles intersected. Now I'll use my line segment tool and I'll connect those to make my triangle. Now there's a lot of other things in the way here that I wish I didn't see, so I'm going to actually hide those things that I don't need. I'm going to select these points and these circles, and I'm going to go to display and I'm going to hide them. Oh, what happened there? Let's go back. Oh, I accidentally had this line highlighted as well, so it got hidden as well. So I'll hide the things that I don't care about right now, and now I've got my triangle. Now my triangle, I'm going to measure, let's see here, the lengths of its sides. Okay, so I've got from A to A prime here is now 5. That's a little confusing, so I'm going to just change that to a C. Okay, so now from A to C, my length is 5 centimeters, so that line there is 5 centimeters. From A to B, that's 4 centimeters, and then this side here is 3 centimeters. So now I care about the angles that are between all of those points. So I'm going to show you how to measure the angles on a triangle here. So I'm going to select A, then B, then C, and I'll go up to measure, and I want to measure the angle. And it gives me angle ABC is 90 degrees. So what that's saying is that the angle from A to B to C is 90 degrees, or this angle up in this corner is 90 degrees. Now I'm going to find the angle at C. So I'm going to click on B, C, A. I have to deselect this angle, and I'll measure that angle. So now BCA is 53.13 degrees. And now I'm going to measure angle A. So I'll go C, A, B, and I'll measure that angle, and I get 36.87 degrees. Okay, so now those are my three angles all over here. So that's the first part of this activity. Then it says, measure the interior angles. We've done that. Construct a second triangle with sides 6 centimeters, 8 centimeters, and 10 centimeters in length. Measure the interior angles of that triangle. Okay, so I'm going to kind of interrupt the video here for a second, and I'll do the second triangle the exact same way I did this first triangle, but with the new side lengths, and then we'll continue. Okay, so now I've got a second triangle here, which has lengths that are twice as long as the lengths in this triangle over here. So if you look, these two triangles look to be the same shape, but this one's about twice the size. That's what we're referring to when we call them similar triangles. So let me just measure a few of these things and make sure that all of my lengths worked out. So I'll highlight those three sides and I'll measure their lengths. And now I've got 8, 6, and 10, which is double the lengths of the first triangle. Written in a bit of a different order there. But if this one were on top, then you can see that this second triangle here is twice the length of the sides in this first triangle. So I'll put those measurements over here because those refer to that triangle, this triangle over here. And now I need to measure the interior angles. So I'll go D, F, E, and I'll measure that angle. And it's over here, 90 degrees. Then I'll measure F, E, D, and F, E, oh, sorry, I need to deselect that angle there. So F, E, D, and I'll measure that angle. And then I'll go E, D, F, and measure that angle. Okay, so now I've got 90, 53.13, and 36.87. So these are the angles for my bigger triangle. These are the angles for my smaller triangle. And if you compare those, you should notice that they are the same. So that proves that this triangle and this triangle are similar triangles. They are the same shape, but this one is a bit larger. You should be able to use that information to help you with the rest of the questions from that activity.